Welcome back to the channel. In this mini-series I'm showing you how I built this performance edition and the little things that I did differently from typical North American construction. Today I'm talking about insulation, and not just any insulation, but one of the most misunderstood, underrated insulation, dense pack cellulose. So let's get into it. In last week's episode, I walked you through all the different layers in the wall assembly and how I built this house essentially as a Gore-Tex jacket. Warm and airtight on the inside and breathable on the outside so that moisture can escape and not cause any damages in the walls. This concept only works if you choose the right insulation, and for me there was a clear winner: cellulose. Cellulose insulation checks all the boxes. Let's rapid fire. It insulates well. R3.5 per inch. It's quick to install with the right equipment. Material cost is low. It fits into any shape cavity. It's low in upfront carbon. It regulates indoor air humidity. It is flame resistant. And all of that makes it perfect for this build. Let's look at how I installed the dense pack cellulose. When I built this edition, I had a different machine than I have now, but Pinwheel has an X-Flock machine made in Germany. It's specific to these kind of blown-in insulations. There's multiple types. I'm using it for cellulose, but it can also blow in straight wood fiber, which we have a really cool manufacturer now here in Canada as well. When I was framing the addition, I was drilling the holes for the spots to inject the insulation from, and it was easy to see where I'd be able to come in with the hose to install the cellulose. There are a few spots where I had to use mineral wool because I just didn't have the space to blow in cellulose, so I pre-installed that before I attached the wood fiber board on the outside. One of the key elements I like about cellulose is that it fills every single cavity. When you use a bat and you don't cut it perfectly, or if you cut it perfectly but let's say your lumber isn't perfectly straight, you may have little gaps between the insulation and the lumber, and that allows for moist, warm air or any kind of air to travel and essentially shortcut between the inside and the outside, especially if it's not airtight. But even if it's airtight, you can have convective air movement in there that transfers moist air to the outside, and it can condense on the cold side. I haven't done the exact comparison to determine whether the following is true, but I found out from a German carpenter who said he actually really likes cellulose because he can very quickly close up the wall and maybe the roof and then only install the cellulose later. So he doesn't need to wait for insulation to be installed, have the cavity open for some time, and then maybe have the risk of raining into the wall cavity and then close it up. With the cellulose, he's able to reduce that step or avoid that step during installations of the air barriers and then only install cellulose later. So for him, there was actually a huge time-saving component. I do see how it's very fast to install this. I know that North American bat insulators are also very fast. Most of the time they are not as thorough as I would like it to be, but I haven't quite 100% confirmed whether or not it's actually faster for this kind of application. One of the most common concerns that people have is about settling. Let me show you something. This is a bale of cellulose. It is pre-compressed before installation. I can even stand on it. It does compress a little bit and it bounces back. This material doesn't settle. It's stable. The fluffy stuff that you see in attics that is loose filled, yes, that is expected to settle. And installers will actually calculate how much it's going to settle so that they know exactly what height after settlement it's going to be so that they reach the desired insulation value. The trick is to find the sweet spot in between the bale and the loose packing. And it's been found out to be at 3.5 pounds per cubic foot, where you're not wasting any material and it's stable for the long term and stays put without any settlement. So settlement becomes a non-issue. Let me show you in practical terms what that looks like. I shot a video of how I blow cellulose into a test volume. The exact volume is 8 cubic foot of this volume. And the reason that it's used for testing is that I can now dense pack cellulose in there and then weigh the entire box. With that test, I can confirm whether or not I'm hitting the 3.5 pounds per cubic foot or not. In this video, you actually see me blowing in the cellulose with a nozzle. And as it turns out, I didn't have the machine set up quite correct, and I achieved just about 3 pounds per cubic foot. In my second test, I actually installed the hose into the opening, and as I filled it, withdrew it, I changed the settings of the machine so that I actually got a little bit less material with more pressure, and in the end I actually achieved 4 pounds per cubic foot. That's more than enough to prevent any kind of settling. In the end, I open up the lid, and you can see that it's a little bit irregular right at the spot where the hose was introduced, and it bulges out a bit. It's not quite as even as at the bottom, but overall it achieved the density that it needed. I was even able to tilt the entire box down to show you the material is packed in so tightly that it won't even fall out. Here are some shots from a previous job site where I installed cellulose in the wall with TGI installed on the outside and then dense packed cellulose. There was a mistake done by one of the planners where the window opening wasn't indicated correctly, and we had prefabricated the window a little bit too small. We then needed to cut that open and enlarge that a bit. But just to show you, the insulation above the window opening didn't even fall down, even though I cut it out, and you would think that the cellulose would fall down. Last thing, let's talk fire safety. Cellulose is treated with boric acid and minerals to make it both fire resistant and pest resistant. The fact that it is tightly packed in the walls also limits the amount of oxygen that could actually get to the cellulose to fuel the fire. Let's make a quick test. I'm holding this cellulose in my hand and I'm using a blowtorch to put flame right on it. I've seen other guys actually put a penny on top of that, showing that the penny became red hot while the cellulose was not burning up, and you can't actually feel it on your hand below. Right after I removed the flame, I waited a little bit because obviously the charred cellulose has some heat to it, but you can see that immediately I can already start poking around in it. This also demonstrates another thing. The weight of the cellulose in the walls is significant. This is actually what is needed to prevent the hot heat in the summer to penetrate through the wall. In building science, we call this a phase shift. We talk about a phase shift. That means the heat that hits it on the outside takes X amount of hours to reach the inside. Generally, we aim for a phase shift of 12 hours or more, which means that the hot sun that hits the wall at, let's say, 1 p.m., 2 p.m. will take 12 hours to migrate all the way to the inside. By that time, we're already back in the night and the wall is already starting to cool down again. So if you're looking at the temperature curve of a wall like that, it ripples like that, but it has dramatically decreased that ripple and just very slightly goes up and down. Summer heat protection with cellulose is also a big thing, and I can confirm that from this edition, which is my office, that it works really well. We have very hot days, and this room stays cool significantly longer than the rest of the house, which is insulated with conventional fiberglass bat. There are 2 other videos on YouTube that I'd actually like to point out which did some really cool tests for cellulose. The unfortunate thing is that they're in German. In case you're interested, the first one is from a company called Otthaus in Germany, and they're showing how they're taking a wall cavity, filling it all the way up with dense packed cellulose, and they're dropping it from roughly 12 inches. The reason why they're using 12 inches is because it could be common that you accidentally drop the wall. Generally, you place them fairly carefully, but in prefabrication, if you just ding that wall panel down, it can happen. And they're showing how they're unscrewing the panel at the end and there was no settlement. They're comparing that to fiberglass and they're showing there was actually significant settlement with that material. So I think that's a really cool demonstration of what dense packed cellulose is capable of. Another really interesting video is one where they're comparing multiple walls against each other and they're holding a heavy duty propane burner onto this wall section and they're showing how long it takes for that to burn through. Here you can see that the sections packed with cellulose actually held up very long. I don't know offhand right now at this point, but in the end they just turned off the burner. It did not burn through. And lastly, how about maintenance or just the building in the future in general? What is really cool with cellulose is that it can actually just be reused. If nothing had happened to it, you can just put it right back into the hopper. Just make sure that there's no dirt in it. So on a construction site, I usually keep the site clean so that any of the material that blows off, you can actually just collect again, throw in the hopper, and there's very little additional material that gets thrown out. Another interesting fact I think from Germany is also that cellulose insulation is the only insulation that can go into regular garbage. Over there, they're very specific about how to recycle the different material at end of life. And all the other insulations need to be treated specifically, whereas cellulose insulation can just go into regular garbage. And if you're being more specific, even boric acid is even used in agriculture. So you could actually technically just spread this material out on a field and it wouldn't hurt it. Also, one thing that we barely ever talk about in North America is what do we actually do with a building at end of life? How do we build it back? Or how do we reuse it? Or how do we recycle the materials? With cellulose, that's very easy. You just pump it out. You just need a big vacuum and you can remove it. If you compare that to, let's say, spray foam, that's very hard to remove from the other materials and to separate out. So for me, cellulose, and specifically dense packed cellulose, hits all those marks. What do you think about it? Would you have used it or would you just stay away from it? Let me know in the comments down below if you found this helpful or if you have any concerns or questions. I'd love to answer them all. Next week, I'll go into the windows and the door that I installed in this edition, how I installed it, which windows and door I chose. So if you want to see that, give me a like and subscribe so you don't miss that next episode. See you then!